Hey y'all, I wanted to do a quick recording on Z-score, standard score. It's a concept that gets introduced a little early, and I'm trying to support a little bit of understanding before we dive deeper into how we use those things. Um, so I pulled up a question, and this is actually from section 2, and um, this is a lot of words. Got some data here, so I'm going to see if I can copy this to the clipboard. If not, I'm going to have to do it by hand. Something's happening. And no, that did not work. Okay. So let's just grab it here. Oh, I'm going to have to download it, open it up. There we go. All right. Got two machines producing a lot of bolts. Generally, I'll do this. Generally speaking, looks like they're supposed to have a length of 84 millimeters, but if we get our really precise measurements out, they're not exactly 84 millimeters, but they're pretty darn close. And I think this is pretty legit for machining, but I don't have a lot of experience in machining, so I can't tell you how, realistic this is. So the thing we need to know about the Z-score is that the Z-score, maybe zoom in a little bit here. In words, what is the Z-score? It is a standardized measurement that looks at how many standard deviations away from the mean a single data point is. That's what the Z-score is. And the standardization is nice because if I say I'm 3 millimeters from the mean, and here in this one, I'm 2 millimeters from the mean, well, 3 millimeters may be farther in terms of millimeters, but if the data is more spread out or less spread out, then that has an impact. And so that's why we're comparing it or standardizing it to be how many standard deviations. So that's really the first thing I need to do is get the standard deviation and the mean, and then I'm able to do my Z-score calculation. And ultimately, the Z-score is a pretty simple formula. It's just got three parts to it, which is the data point minus the mean. That's how far away is the data point from the mean over the standard deviation, which is, how much variance in general on average is there. And I need to look here to see if it's clear what they want me to do in terms of the standard deviation. Because remember, with standard deviation, we have population, we have samples. I see the word sample here. That's very important. So that means that when I do the standard deviation, I should use the standard deviation.s. And so I'm going to do that for machine A. I'm going to do that for machine B. I'm using that control shift down trick, command shift down if you're on a Mac. All right, and then I need the mean. The mean, of course, in Excel is average. And shift down, go, and for B, average. All right, so now I have what I need. These are both very, very close to the mean that the length that they're supposed to be, which is the 84 millimeters. This one's a little bit longer. This one's a little bit shorter. Again, who knows if anybody if that would make a difference in terms of using this bolt, but we can mathematically look at this and say, yep, there's a slight difference here in terms of what the machines are producing. And in general, I would say, although these are very close standard deviations, machine B has more variance, has more variation because I see the standard deviation is slightly higher. Pretty similar, but let's just see how it impacts the z-score. So the z-score is the data point minus the mean divided by the standard deviation. The data point, I think, was provided in this question as 84.05. So 84.05, let's get the parentheses in here, 0.05 minus the mean divided by the standard deviation. I can autofill because I've set this up in a way that I can see that's F7 and E7, and then here I'm going to use F8 and E8. And so I think the biggest thing impacting this and making this one so much bigger than this one is just that the 84.05 is closer to is on the large side. So because the mean is on the small side, it's just we're further away from the mean. So we're saying we're a lot of standard deviations, 3.5 standard deviations away from the mean. We're not going to talk about what that means and the interpretation of that. We just need to answer that question. And so, yeah, 1.74, 3.57, and that's rounded to the nearest hundredth. So, okay. Hope that helps. And I'm going to post that. And yeah, let me know if you have more z-score problems. Again, the formula for the z-score is just take the data point minus the mean and divide by the standard deviation. But you do need to pay attention here to the fact that you have order of operations and subtraction needs to happen first. Sometimes what you see is students doing this, 84.05 minus this divided by this. Order of operations here says divide, then subtract, and this is a wildly different answer. Z-scores in general should be kind of small, could be positive or negative, but kind of small numbers close to zero. 1, 2, 3, those are normal z-scores, -1, -2. Sometimes I can get 5 or 6, but this means there's a mistake. There's probably a mistake. Okay. Hope that helps.